viewers. In the first part of the film on production planning and control, we dealt with production planning. Under this topic, factors based on routing, estimating, scheduling, loading, dispatching, and also forecast for central tendency, last usage, moving usage were explained. Now, these are the basic ideas for production planning for any product which is to be marketed to the public. In this part of the film, we will go through control, which contains material control, batch control, and production control. Okay, so let us watch the film.
Now, we shall be discussing production control, and especially first we will put emphasis on material control. Now, why material control is that important? You know, if we look to actual production processes, then in some of the product, the material cost is very high. Generally, you know, material cost may vary from 25% to 75% of final product. Now, in the final value of the product, if the cost of material is very high, then its control will be very, very important, because it is significantly contributing to the value addition in a product. Say you take for example the thermal power plant. Daily, you know, large number of wagons of coal, they are being consumed. You look to the cement plant. Now, the quantity of limestone which is required for producing your final cement, you know, it is quite huge, and its carrying cost may be very high. Suppose there is a thermal power plant at Bhatinda and coal is coming from the Bihar. So, daily, you know, 100 wagons, if the requirement is that 100 wagons are to be used per day, then 100 wagons have to be brought from Bihar to this place, and if you add the total cost of the material consumed in the process, it is very huge. So, you know, handling, its processing, its use, it is very, very important. You have to control the material in such a way that there is a minimum requirement of material, and at the same time the inventory cost for the material is also very low. Now, if you look to the usage of material, then you know, you find that in order to take care of certain eventualities, like, you know, there are holidays, there may be a strike in transport, there may be some power failures, some production problems in raw material producing companies. So, all those factors if you keep in mind, then you know, certain amount of stock, you know, you have to keep in your factory so that your production can continue without disruption. You know, some companies may be keeping a stock for 7 days, other companies may be keeping 15 days, 20 days. It may vary from company to company and also from product to product. You know, if the source of raw material is very close and you can procure it very quickly, lead time is very less, you can keep the stock at a very low level. But suppose the material is imported and you know, you can't have any local material to replace it, and then your procurement time is pretty large, then probably, you know, in certain cases even you have to hold the material for longer period. Idealistically speaking, you know, your material stock holding should be as minimum as possible, because it is adding only to the cost, it is not adding to the value. If your systems are very, very efficient, and suppose the raw material comes and it is being processed and final product is sold out, that is the most efficient way of converting the raw material into the finished good. And there, you know, it is a just in time. That means things are coming when they are required. if that is possible, then cost of final product will be minimum, but in most of the cases that may not be possible. Even companies which are very efficient, they may be having stock of few hours or few days. In Indian situation, the stock holding may varies from 1 week to even 1 month. Now this you have to find out in advance by estimating the requirement of raw material based on what are the products you are going to manufacture. Now once you have found out what is the stock holding, then constantly your objective should be how you can reduce the stock by having better management, by having better control. Can you reduce the holding? As I told you, holding is only adding to the cost, it is not adding to the value. If your material remains in your store or in your factory, in shop floor, in between different workstations, then it is just waiting, and things like waiting, queuing, searching, all that thing, they are a kind of a waste. They are not adding value to the final product. When material is being actually processed, only during that period value addition is taking place. When it is just lying in the store, then it is a requirement because our systems are not so efficient that we get the thing when they are required. And if we do not get them when they are required, our production may not be continuous and we may have to stop it. And when the production stops, then your machinery is idling or your manpower is idling, and because of this idleness of manpower and machinery, cost of product will go high. So in that case, our aim is to reduce the stock holding, but certain minimum level of stock will be required for carrying out the production activity. Then comes the question of stock replenishment. You are having certain stock, but then when you are using the raw material for producing your goods, then the level of stock will go down, and at certain point of time you are required to procure fresh raw material and add it, so that again the stock level is brought to whatever the level you have decided based on your production targets. So economic order quantity, reorder level, and all those things have to be estimated in advance. Economic order quantity, for example, you are procuring the raw material, then if it is coming by truck or by wagon, then some minimum quantity is required to be purchased, so that the cost of procurement is minimum. So keeping that thing in mind, you try to fix up economic order level, and you also fix up your minimum level and maximum level of the stock, so that you can have proper control on the raw material usage as well as storage. Second thing, in storage also, if storage is not proper, or in transportation if it is not handled properly, there are chances of spoilage of the material. If material is coming directly on the machine, then this storage, multiple transportation and all that thing, they can be eliminated. That is the best thing if it is possible. But if it is not possible, then in that case receipt of material, its inspection, its storage, again when production machine requires it, it will requisition it from the store, it has to be transported from store to the machine, and all these things will require additional activities, and those additional activities will cost extra money. So, if they are must, if they are essential, they have to be incorporated. If they can be eliminated by designing better systems, if infrastructure is improving, if other systems are improving, then we can keep on reducing our stock levels. Then your control system, what kind of control system you are having, and different industries they are having different kind of system. In some industries they have a 2-bin system.
Okay.
And yeah, when one raw material from one bin is finished, and when you start using the second bin, then they place an order for a new bin and material comes. So like that that is a kind of a system. But before we adopt a system, we should be clear about the ABC analysis of the material. When we want to control our material, this ABC analysis, which is shown in the graph here, is very, very important. Now, what is this ABC analysis? On x-axis we are plotting the percentage product range, and on y-axis we are producing the percentage value of the product. Now, here you will find that 10% of the product, they are having 70% of the value. For example, you look to a car. Now, engine, gearbox and differential, some of the items may be only 10%, but if you look to their total cost compared to the cost of a car, then 70% of the cost may be only of those few items. Rest other items, their quantity is large, but their value is less. So, in many situations you will find that a very less percentage of product is having very high value. In this figure 10% of the product, they are having 70% of the value. Now, products falling in this 10% range, they are known as category A product. They are classified as A class product. Then next 20% of the product, they are having 20% of the value. So, if you see at 30%, the total value is 90%. What does that mean? That additional 20% of the product, they are adding only 20% of the value. And this particular range of product, it is known as B class product. And then remaining 70% of the product, they are adding only 10% of the value. So, this product is categorized as C class product. Now, why do we do this ABC classification? Because when you want to control the material, you have to identify which are the materials on which we should have a very strict control. Can you tell me which material should have your maximum attention or maximum control? It is category A material, and moderate control on category B, and least control on category C. So, here category A, category B and category C. Maximum control have to be on category A material, because 10% of these items, they are adding 70% of the value. If you are having maximum control here, then you can improve the productivity to a larger extent. So, lesser effort, better return. And here 80% of the items, they are adding only 10% of the value. Even if you put lot of importance to these kind of a thing, the actual improvement will be very small, because that total value is very, very small. So, keeping that thing in view, we try to classify the materials which are being used in the industry in category A, category B and category C. And persons who are controlling the material, they try to control the material which are in category A to a very great extent. That is, maximum attention is paid to that category of material. So, this ABC analysis is clear. Now, this helps a great deal, in control of the material. Now, I will proceed to production control. Under production control, types of production control. First is the order control. In order control, we are receiving a order from a customer for certain quantity of items, and for that quantity, we place the order in the production shop, and production shop, they will produce those many items after receiving the order. So, here it is a kind of a batch production. Now, next is flow control or rate control. When we are having continuous production, then we try to have flow control or rate control. Suppose there is a cement plant or fertilizer plant where continuous production is going on, but there also we have to control the rate. Say 200 ton per day is the production capacity of a cement plant, then we have to ensure that all the machineries, equipment and processes, they are set in such a way that 200 tons are produced at the end of day. If actual production is less than this, we have to see why it is less, and wherever there is a problem, either in plant, equipment or process variable control and those kind of things, they have to be corrected. So, this is known as a continuous production control. And there in process control is also very, very important. Say you are manufacturing a fertilizer, or if you go to a chemical industry, then your temperature, pressure, they affect the reaction which is taking place between different elements. And there if you are not able to control these variables in some specified limit, then you may not get a product of a right quality. So, there production process is a continuous one, but in that continuous one also, whatever are the critical elements, you are controlling them. Temperature should be maintained within say 80 plus minus 1. Now, there may be a centralized control, there may be a decentralized control. In centralized control, all the variables, they are being transmitted on the control panel and you are getting the reading. And when they are going away from the limits, then you take the corrective action. So, here this is applicable in case of flow control or rate control. Next is your block control, and in block control, for example, in manufacture of car, there may be many models of a particular car, and the production planning control department, they have decided that these items will be prepared in certain blocks, and they give a order. They give a order, such and such model, you prepare for 6 hours, then switch over to second model, then switch over to third model. So, in blocks, they are producing different goods, and at the end of month, they are getting these goods in certain quantities, and that is being matched with what is the requirement in the market. So, the actual requirement, is converted into blocks, and then order is placed in blocks in the production shop, and they are manufactured in blocks. Now, it is for the production planning department to decide these blocks. So, whether it is a batch or whether it is a block, the amount of machineries you are having, the number of products required, the number of people you are having, all those factors, the kind of processes which you are using, all those factors have to be considered in deciding the batch size or the block size. Now, then the load control. Now, here there is a loading on different machines, there is a loading on different people. Now, it should not so happen that some people are heavily loaded and some people are very lightly loaded. What will happen in the industry? They are also watching each other, and if you have planned your production in such a way that some people are getting more load and other people are less loaded, then all the workers, they will not be happy. Those who are highly loaded, they will have a grudge that why certain other people, they are less loaded. So, there you have to load, you have to control the loading of the people in such a way that there is a kind of a equal distribution, and then you are getting the optimum return by that kind of a loading. Some variation is possible, but ultimate aim is you are getting optimum output from the machineries, from the people you are having. Now, next is spatial control, spatial project control. Now, the name itself, spatial project control, it indicates that each project is a new one. Say you are constructing a Bhakra dam, or you are doing a task which is entirely different, only one particular item has to be fabricated. A large plant for a paper mill or a sugar mill is to be prepared. Now, only one item is to be prepared. Now, for that, or one building is to be constructed. Now, for that, it is a special project, and you have to prepare detailed plans only for that particular thing. In mass production or batch production, items are prepared in a repeated way. Here, it is an individual item or a individual special project which is to be executed, and there the planning may be even slightly different. For example, a spacecraft is to be launched, or in defense, you are trying to develop some special equipment, and it is the initial development of that kind of a equipment. So, in that case, sometimes we are not that particular about resources, but we are particular about achieving our targets. Or war is going on, and order is that such and such item should be available because it is very critical. Then looking to various factors, you have to plan, and it is a special kind of a project, and the considerations which were considered earlier, they are applicable here also, but there can be some deviation from them depending upon the new requirements which are there for that particular project. Are you getting my point? Sometimes there can be a deviation from generalized requirement because of special features needed in a product, or the time schedule is such that by routine methods you will not be able to cope up with that kind of item. So, those kind of things they are taken under spatial project control. So, in production control I have discussed the material control, then the production control.
So viewers, in the second part of the film on production planning and control, we learn the techniques of control, which contains material control, batch control and production control. Control puts emphasis on production quality, marketing technique, etc. In a nutshell, the film on production planning and control has given you an in-depth study to produce products by proper planning, adopting the techniques of control. We hope this film will help you in planning better to produce good and quality products. Thank you.